Hello there. This is the review sheet for the Common Core Algebra Midterm. The exam will be on Wednesday, January 28th from 8 a.m. to 10 a.m. Please come prepared. Bring something to write with. Bring your calculator. Here you have your 5 songs. The songs are on the YouTube site. And once again, the whole point of the songs is for you to write it out. Because once you write it out, you have it. So, once again, you can see the YouTube site, which can be found on symmetry.com. X equals. Right now, we don't have x equals, so we need to get it so that it's x equals. So, we know to isolate the add or subtract first. Add 2, we get bx equals k plus 2. I'm not done yet, I divide last. I'm left with x equals a plus 2 over b. The next example is pretty much the same type of question. This time it wants a equals. So I add or subtract first. I can't combine like terms, so I leave it as x plus b squared. I divide last, and I get a equals x plus b squared over 2. Next type of question. Rational and irrational. Rational numbers are nice, organized. Irrational numbers are crazy. If it goes on forever and there's a pattern, it's rational. If it goes on forever and there's not, then it's not. With radicals, perfect squares are rational. Non-perfect squares are irrational. Non-perfect square, irrational. Perfect square, rational. Perfect square, rational. Non-perfect square, irrational. When we're adding values, for it to be a rational answer, they have to only be rational numbers. B and C are rational, therefore B plus C is rational. Number 4 is pretty much the same thing. Fractions are always rational. Non-perfect square, non-perfect square, B plus C again. You need to know your properties. On page 2 of your key understandings packet, you have all your properties. Inverse is when you end with 0 for addition or 1 for multiplication. We end with 1. Choice 3 is your answer. Choice 1 is identity. When you start and end the same thing. Choice 2 is multiplicative property of 0. Choice 3 we just talked about. And choice 4 isn't actually really a property. Number 6 is another properties question. There's 2 sets of parentheses. However, being how we have the same thing in both, it's not associative, but it's commutative. It's the move-in property. 3 and the 4x are moving away. You can do this with the calculator or without the calculator. Without the calculator, absolute value of negative 11 is 11. If the distance from 0 is always positive, absolute value of 12 is 12. 11 plus 12 is 23. You could also do this problem in the calculator. Now, my calculator, unfortunately, does not have the new software that's on here, but it's the same buttons. You would hit Math, Num, ABS, negative 11. Of course, yours will show the bars, plus Math, Num, ABS, 12, and that gives me 23. Same thing for number 8. I'm going to do it only by hand. Absolute value of negative 6 is 6. Absolute value of 8 is 8. Minus in between them. 6 minus 8 is negative 2. Subtracting polynomials. A minus B. I'm going to write A. Minus B. To subtract polynomials, you need to know keep, change, change. Of course, like everything else that's listed in your key understandings packet. So we keep the first polynomial. We change subtraction to addition, and we change everything in the second one. Positive 7 becomes negative 7. Positive 3 becomes minus 3. Plus 2 becomes minus 2. From here you combine like terms, same sign, add the numbers, keep the sign, different sign, subtract the numbers, take the bigger sign, same sign, add the numbers, keep the sign. Number 10, same type of question, except this time it says b minus a, so I'm going to write the b first. Minus a. Keep. Change. Change. Negative becomes positive, plus becomes minus, minus becomes plus. Combine like terms, 7 plus 2 is 9. 3 plus negative 5 is negative 2. 2 plus 7 is 9. Now, for multiplying polynomials, you need to know to do the box. So, I made a 3 by 2 box. 3x squared plus x minus 5, x minus 4, and put in your coefficients and exponents if they're missing. That will limit mistakes. When you're doing box method, you're multiplying. 1 times 3 is 3. You're adding the exponents. 1 plus 2 is 3. 1 times 1 is 1. 1 plus 1 is 2. 1 times negative 5 is negative 5x. Negative 12x squared, negative 4x, positive 1. Now that I have this, I just combine like terms. 3x to the third stays. My x squared, I combine. When you're combining like terms, add. Negative 12 plus 1 is negative 11. X squared. Negative 4 and negative 5 is negative 9. Plus 20. Done. Next example, same type of question. 2y squared minus 3y minus 1, y plus 7. Put in the 1, put in the 1, put in the 1. 1 times 2 is 2, 1 plus 2 is 3. 1 times negative 3 is negative 3, y squared, negative 1y, 14y squared, negative 21y, negative 7. Now I combine my terms, 2y to the third, 14 plus negative 3 is positive 11, negative 21 minus 1 is negative 22, and it's done. Equation solving. We have our song, fractions, parentheses. I'm going to write that out. Fractions, parentheses. Combine like terms. Bring all x to one side. Isolate. In order to do that, we add or subtract first. And even though it's not the song, you do have to know if you're adding and subtracting first, you're dividing left. And your key understanding stack talks about how to do each of these steps. So there are fractions. To get rid of fractions, I multiply by the LCD, which is 6x, because 6x is the smallest term that all my denominators go into. The reason I do that is not to multiply, but to get my denominators to cancel. 6x over 6x cancels, that's 3. Plus 6x over 2 is 3x. 3x times 1 is 3x. X and x cancel. 8 times 6 is 48. 6x over 3 is 2x. 4 times 2x is 8x. I got rid of my fractions. Parentheses, no parentheses. Combine like terms, I can't. Bring the x to one side, I have to do that. I bring the smaller one to the bigger one. Isolate. In order to isolate, I add or subtract first. Minus 48, minus 48. That gives me negative 45 equals 5x. divide last, divide by 5, divide by 5, x equals -9. We got another one here. There's no fractions. There are parentheses. Take rid of the parentheses and distribute. 8z plus 6 equals 7z plus 4. Combine like terms, no. Bring all x to one side, yes. In this case, we bring all z's to one side. We have z plus 6 equals 4. Isolate and subtract first. Z equals -2. Fantastic. Whew, inequalities. Same thing as equations. No fractions, no parentheses. I can't combine like terms. I don't have to bring all x's to one side, but I do have to isolate. And in order to isolate, I add or subtract first. And I divide last. To graph this on a number line. There's 0. There's 3. It's a closed circle because of the equals. And because of the less than symbol, I'm shading to the left. I have another one here. Yes, I do. No fractions, no parentheses. I can't combine like terms, but I do have to bring all x's to one side. Always bring the smaller one to the larger one to keep everything positive. 4 is greater than 3x minus 2. Isolate, add or subtract first. Divide last. Now this is kind of written backwards, so to switch it around, being how the pointy side is facing the x, when I rewrite it, the pointy side needs to keep on facing the x. And I get x is less than 2. The graph on another line. Open circle, great less than is to the left. And I'm done. 17, sequences. As soon as you see sequences, please turn to your reference sheet and get the formulas. You have to determine if it is arithmetic or geometric. The pattern is +2, which makes it arithmetic. Arithmetic is where you're adding. Geometric is where you're multiplying. The formulas are on your reference sheet. an equals a1 plus n minus 1d. A sub 1 is the first term. The first term is 3. N minus 1 is n minus 1. D is the common difference, which is 2. From here, all you have to do is distribute and then combine like terms. A sub n equals 3 plus 2n minus 2. And when you combine like terms, you get 2n plus 1. They're both 2n plus 1, whatever. That's how you do it. This one, again, plus 3 plus 3 plus 3 is arithmetic. Same formula. I wonder if I put some geometrics next. I guess we're about to find out. A1 is -5, n minus 1 is n minus 1, d is 3. Distribute. A sub n equals 3n minus 8. There we go. Here we go. As we can see, this is not arithmetic, because if it was arithmetic, this would be plus 6. This would be plus 6 again, and as you can see, the third term is not 25. So, I'm multiplying. What am I multiplying by? Well, it's not an integer, because 4 times something is not 10. The easiest way to determine that is just to divide. 10 divided by 4 is 2.5. Times 2.5 is 10 times 2.5, 25. Sure is. If you're not sure, check your calculator. Again, times 2.5. So I recognize that it's geometric. Again, go to your reference sheet. Do not waste your brain power on memorizing a formula that's given to you. Geometric's easier. You don't have to distribute and combine like terms. The first term is 4. R is the common ratio, which is 2.5. N minus 1 is N minus 1. Do not multiply these. Leave it like this. 4 times 2.5 to the N minus 1 is right there. Same type of problem, just a little bit of a word problem. An initial value of 10. That means that a sub 1 is 10. Each term is twice the previous term. So then a sub 2 would be twice that, which is 20. A sub 3 would be twice that, which is 40. So the common ratio is 2. An equals a sub 1, r to the n minus 1. A sub 1 we said is 10, r is 2, the n minus 1. What do we got next? Ooh, recursive. Remember, a sub n minus 1 means the previous term. So if they give me the first term, all I can find right now is the second term. Again, if I'm finding the second term, n minus 1 would be 1, or the first term. It's easier to just think of it as the previous term. What comes before the second term? The first term. A sub 1 is negative 3. You can put this into the calculator from here, whatever, you get 13. Now that I have the second term, I can find the third term. The third term would be 4 minus 3, a sub 2. Again, previous term. 2 comes before 3. What is the second term? Well, I just found that. The second term is 13. I can put that into the calculator from there if I want to get my answer. I believe that is negative 35. Probably get a calculator at this point. I'm a little bit too late. A sub 4 is 4 minus 3. The previous term would be a sub 3. A sub 4 equals 4 minus 3. A sub 3 is negative 35. You can use a calculator if you want. I don't feel like it. That's 109. If I'm wrong, correct it. We have another example here. It's giving me f of 1. So, again, this is the same thing as a sub n equals a sub n minus 1 plus 2n. Same thing. In fact, I'm going to think of it as this if we're using that notation. It's giving me a sub 1 is 16. So I find a sub 2. A sub n minus 1 is a sub 1 plus 2. N is 2 in this example. N is whatever term you're finding. A sub 1, again, is 16 plus 4, which is 20. Now that I found the second term, I find the third term. A sub 3 equals, well, a sub n minus 1 is a sub 2 plus 2, n is, in this case, 3. N is, again, the term that you're finding. A sub 3, well, a sub 2 is 20 plus 6, which is 26. And finally, that is the third term. I can find the fourth term. That's a sub 3 plus 2 times 4. A sub 3 is 26 plus 8. The fourth term is 36. Solve the following system of equations. Well, this is addition method because the variables are lined up. You can refer to the key understandings for all the steps. I have to choose a variable to cancel. I'm going to choose the y's. If I'm choosing the y's, I multiply each equation by the other one's coefficient. The signs should be different. They are. If they weren't, I'd have to multiply by a negative. I distribute, I get 3x minus 3y equals negative 3. And I get 5x plus 3y equals 1. Now that I have that, I add them together. 8x, these cancel. Whoops, I missed something there. That's with a negative 9 equals negative 8. Divide by 8, divide by 8, x equals negative 1. Now that I have the x value, I have to substitute in to find the y value. It doesn't matter which one we use. X is negative 1, so I replace the x with negative 1, and then I solve the equation. Add 1 to both sides, negative y equals negative 2. Divide by negative 1, y is 2. You might see your answer written as an xy coordinate. The x value is negative 1, the y value is 2. 24 is another example, pretty much the same thing. Let's choose the x's in this example. I'm choosing the x's to cancel. I put a 9 here and a 3 here. They're both positive, so I have to make one of them negative. It doesn't matter which one, but I have to just pick one. Distribute it out. 27x minus 9y equals 9. And we got negative 27x minus 72y equals 9 times negative 17 is something. Let me get my calculator at 9 times. That must be 153. Hope so. And those together, x's cancel. Negative 9 plus negative 72 is negative 81y. 9 plus 153 is 162. I solve the equation, divide by negative 81, divide by negative 81. Y equals, sure enough, negative 2. Now that I have the y value, I just sub in to find the x value. I'm going to choose the bottom one because everything's positive, or at least the variables are positive. I'm going to replace the y with negative 2. And then I solve the equation for here. 3x minus 16 equals negative 17 plus 16 plus 16. 3x equals negative 1. Divide by 3, divide by 3. X equals negative 1/3. So as an xy coordinate, your answer would be negative 1/3, comma, negative 2. No? Oh. You need that?
Sorry to interrupt.
Okay. Sorry for the brief delay, we're back. Tim makes wooden salad bowls and sells at a monthly craft fair near his hometown. Nothing mathematical, move forward. Each month he spends $45 in specialty wood and other materials from his local lumber store. Alright, so he spends $45. There's no per, it's just $45. At the craft fair, Tim sells each completed salad bowl for a total of $22, including tax. Express Tim's profit as a function of the number of units that he sells. Well, profit is the amount made minus the amount spent. So, how much did he make? He's making $22 per bowl. So that's 22x. The amount spent well, all he did was spend $45. Not $45 per bowl, just $45. So his profit would be his amount made minus his amount spent. Now that we have that function, how much of a profit would he make if he sold 16 bowls? Well, P of 16 equals 22 times 16 minus 45. You can put that into the calculator to get an answer. 22, let me look it up. 32 times 16 minus 45 is 307. Not a bad profit. Jessica sells necklaces at street fairs on the weekends. Don't care. Nothing mathematical there. Move forward. It costs her a total of $50 for the material she needs to make the necklaces each weekend. It costs her $50. She charges $5 per necklace. So, again, it's asking for profit, and again, I know that profit is the amount made minus the amount spent. Amount made. Well, she's making $5 per necklace. $5. How much is she spending? The amount spent is 50. So, her profit is 5x minus 50. We're up to here. We're not done. How much of a profit would Jessica make if she sells 32 necklaces? Well, P of 32 equals 5 times 32 minus 50. I think that is 110. I'm going to check it in my calculator because I don't want to get a question wrong and make a mistake. But fortunately, I do not make mistakes often, and we have 110 as our answer. The sum of the ages of the three Romano brothers is 63. Awesome. The sum of their ages is 63. If their ages can be represented as consecutive integers, whenever you see consecutive integers, there's three of them, so it's integer 1, integer 2, integer 3, x plus 1, x plus 2. Every time you see consecutive integers, x plus 1, x plus 2. If it's a consecutive even or consecutive odd, it would be x plus 2, x plus 4. Now, the sum of the ages is 63. So, x plus 1 plus x plus 2 equals 63. From here, I solve the equation, combine like terms, isolate, and subtract first. Divide with. Answer the question. The age of the middle brother. The middle brother is x plus 1, which is 20 plus 1, which is 20. The sum of three consecutive odd integers. So as soon as I see three consecutive odd integers, I'm going to stop right there. I'm going to write odd integer 1, odd integer 2, odd integer 3, x plus 2, x plus 4. Now that I have those expressions, the sum of three consecutive odd integers, x plus 2 plus x plus 4, is equals 18 less than 5 times the middle number. Well, let's see what keywords we have. Less than, subtraction. We also know for less than we switch the order. So 18 comes to the back, and 5 times the middle number comes to the front. 5 times the middle number is 5 times x plus 2. That's my equation. Now that I have the equation, I solve it. There's no fractions, there are parentheses. Bring everything else down. Next step is to combine like terms. Yes, I can combine like terms on the left. 3x plus 6 equals plus 10 minus 8. 15 is minus 8. Bring the x to one side. Yes. Isolate and subtract first. divide last. X is 7. Find the three integers. Well, 7. 7 plus 2. 7 plus 4. 7, 9, 11. Moving right along. Lily's limousine charges a flat rate and then an additional amount for every mile driven. The cost for traveling m miles is given by the function k of m equals 12m plus 500. Again, this is the cost for traveling m miles. Well, whenever I have a linear function, it's always per x plus the 1 times p. So, k of n equals 12m plus 500. It's asking for the flat rate charged by Lily's limousine. Well, the flat rate is the one-time fee. The one-time fee, 500. The cost per mile for Lily's limousine, well, the per is $12 per mile. Yeah. I'm busy doing I'm recording something. All right? You good? Yeah. All right. Sorry for the disruption. We have some interested people staying in the hallway watching right now. The function y equals 25 plus 6x. Well, I like it to be in mx plus b form. So I'm going to rewrite it as 6x plus 25. Again, we know it's always per x plus the 1 times b. So, my per is 6, my 1 times b is 25. Let's see what this thing's asking. It's saying how many points will he score each remaining game. Each is the same as per. 6 points in each remaining game. How many points does he have right now? Well, his one-time amount is 25. A car worth $20,000 depreciates. As soon as I see depreciates, I know this is an AP 1RT. Being house depreciation, it's minus. You can refer to your key understanding to see what each thing represents. So, A is always what you're trying to find. P is your initial amount, which is 20,000. R is your rate, which is 8.75%. Now you have to convert that to a decimal. To do that, you move the decimal 2 spaces, or you just divide it by 100. Either way, you get 0.0875. And finally, T is 11. I substitute my values in. X equals 20,000. 1 minus 0.0875 to the power of 11. I always want you to do what's in the parentheses next. Use a calculator if you need to. In fact, I insist, use a calculator. 1 minus 0.0875. I'm going to use a calculator myself. Is 0.9125. And from here, type the whole thing into the calculator. When I type it in, I get 7304.518613. Now it wants the answer to the nearest cent. The nearest cent is 2 decimal places. I get 7304.5. Marissa deposits $2,000 into a bank account. Again, AP1RT. In this case, being how we're depositing money in an account where there's an interest rate and it's getting bigger, I put a plus. APRT. A is always X. It's the current amount. It's how much you'll have at the end. P, your initial, 2,000. My rate is 4.6%, and I have to convert that into a decimal. 1, 2. T is 8. X equals 2001 plus 0.046 to the power of 8. Do what's inside the parentheses first. You can use a calculator for this. Then you type the entire thing in. 2001.046 to the power of 8. I get 2866.048081. To the nearest cent, again, is 2 decimal places. And 8 makes the 4 round up. That's a lot of money. What do we got next? Ooh, Jennifer and Kim enjoy making bracelets. At the beginning of this year, Jennifer had already made 25 bracelets. So Jennifer has already made 25 bracelets. She continues to make 8 bracelets every month. Every month, per month, each month. Per X plus the one-time fee. Now we got 2 girls here. We have Jennifer, we have Kim. This is Jennifer. So I'm going to write J of X equals, well, my per is 8. So that's 8X plus her one-time amount. She started with 25. Now we have Kim. Kim just started making bracelets recently, so she's only made 11 at the beginning of the year, and she's able to work more quickly, so she makes 10 more bracelets every month. So for Kim, her per is 10, and her one-time amount is 11. Okay, write a function J of B to represent the number of bracelets Jennifer has made, and a function K of B to represent the number of bracelets Kim has made. Well, it wants J of B and K of B, so just instead of X, make it a B. During what month this year will Kim have made more bracelets than Jennifer? Well, in order to determine when she made more, let's find out when they made the same amount. To determine when they made the same amount, the 2 functions must be equal. So I said 8b plus 25 equals 10b plus 11. I solve the equation. Bring the X to one side. Isolate and subtract first. 2b equals 14 over 2 over 2, b equals 7. Now it says during what month? Well, at the beginning of this year is January. So the 7th month is Russ is interested in getting a summer job as a busboy and is deciding between 2 different restaurants. Nothing mathematical there so far, don't care, I'm up to here. Let's have we're paying $55 per day plus $2 per table. Well, again, per X plus the one-time fee. They both say per. Which one is the true per? $55 per day or $2 per table? Your true per is the per table. Even though it says $55 per day, that's a one-time amount. He's getting paid $55 once for that entire day. The per is your 2. So I'm looking ahead here. For the tableau, let's call that T of X. Its per is 2. His one-time amount is 55. Now up to Smoky Bones. Smoky Bones will pay him $75 per day plus $150 per table. Again, that $150 is your per. So I'm going to write S of X for Smoky Bones equals 1.5x plus 75. Write a function to model how much money you would make per day at each of the restaurants to find the variables. Well, let's just make a little key here. T of X is money at La Tavola, and S of X is money at Smoky Bones, and X, well, that's the number of tables. So that's your answer to part A. Part B, how many tables would Ross have to bust for the 2 restaurants to pay him the same? Well, same means equal. So we'd have to set 2x plus 55 equal to 1.5x. Whoops, 1.5x plus 75. Solve the equation. Minus 1.5x minus 1.5x. 0.5x plus 55 equals 75. Minus 55 minus 55. 0.5x equals 20. Divide by 0.5. Divide by 0.5. X equals 40. So, 40 tables. For the pay to be, but there's a part C, isn't there? And he busts 35 tables. Which restaurant would he be likely to make more money? Well, I have these expressions right here to determine how much money he'll make. So I'm going to do T of 35, and I'm going to do S of 35. 2 times 35 plus 55, 1.5 times 35 plus 75. Use the calculator if you'd like. I'm going to use a calculator right now because my brain's starting to get a little fried. 2 times 35 plus 55. T of 35 is 125. S of 35 is 1.5 times 35 plus 75, 127.5. They're both pretty close, but if he wants to make money, he's going to make more money. Smoky Bones. That was 34. 35, all right, a smooth one. Function is where each x has only one y. So we look at the x value. If the x values repeat, not a function. X values repeat, not a function. X values repeat, not a function. X values are all different, therefore it's a function. We don't even look at the y values, only the x values. Same type of thing here, which is not a function. Look at your x values. Those are all different. That one's good. All different. Good. Uh-oh. Bad. All different. Good. Which one is not a function? Looks good. For a graph, we do the vertical line test. If there's a vertical line that hits the graph more than once, then it's not a function. This one hits twice, not a function. This one hits twice, not a function. This one hits once. Any vertical line I draw hits only once. This vertical line hits an infinite amount of times, So that doesn't work. Choice 3 is the answer. Same type of question. That's a no. It's infinite amount of times. That one hits twice. Sorry, that was supposed to be straight. So that's bad. Once, once, once. Each one only hits once. That's a function. That one hits 1, 2, 3 times. Geez, that's definitely. That's your answer. Officials are telling you the function C to analyze traffic patterns. Fantastic. C of n represents the rate of traffic through an intersection where n is the number of observed vehicles in a specified time interval. So C of n is the rate of traffic, n is the number of observed vehicles. What would be the most appropriate domain? Well, domain is your x values, or in this case, your n values. So n is the number of observed vehicles. If you're counting vehicles that are passing through, you would start at 0, and then you go to 1, 2, 3. And the key understanding for this is that for these real-life domain problems, your answer is almost always all non-negative integers. If you're counting something, you're starting at 0, if nothing comes, and then you go to 1, 2, 3, etc. Same type of thing here. We're talking about x sets of tires, where h of x is the number of hours. Which would be an appropriate domain? Well, that's sets of tires. You can start with 0 sets of tires, and you make 1 set of tires, and you make 2, 3, etc. The set of non-negative integers. It's a little dark. Which one is a square root function? Well, let's talk about each of them. A u is quadratic. The u has the u. This one is your square root function. If you're ever not sure, you can type it into the calculator and look at it. You can type in y equals radical x and see what it looks like. A line is linear, and a v is absolute. Yeah. You have a whole list of all the functions in your key understandings packet. Again, we have a graph. That's a u, so your answer is quadratic. Find the roots, the vertex, and the axis of symmetry. Well, we have a song for this. The roots hit the x-axis. Another name for roots is zeros. The vertex is the turning point. And the AOS cuts it in half, and it's always x equals. So, the roots hit the x-axis. Boom, boom. -5, +1. The vertex is the turning point. -1, 2, -1, 2, 3. And we say that this is a minimum value. The AOS, or axis of symmetry, cuts it in half, and it's always x equals. X equals what? X equals -2. These will always match. Another example, again, the zeros are the same thing as the roots. +1, -7. The vertex is the turning point. It's a point. -1, 2, 3. And then this one we see down here is -25. They made each box worth 5 there. Good for them. Finally, the axis of symmetry is always x equals. X equals -3. Again, those always match. On the set of axes, graph the function represented by, well, whenever you're graphing, put it into the calculator. Once again, my calculator is a little bit different than yours, but that's okay. We go to y equals. To type in cube the root, I do math, option 4. Yours will look different than mine, but it's the same thing, x minus 2. It gives me a domain from -6 to 10, so I'm going to copy down my graph from -6 to +10. I'm going to only copy down the nice points. Oh, it's gone. I'll get it back. So -6, -2 is good. I don't see anything else, so I'm going to scroll. Remember, I'm going until 10. Oh, there's some nice points. 1, 2, 3. -1, 0, 1. Hopefully I got it down right. Yes, I did. Fantastic. Let's scroll down until I get to 10. Nothing, nothing, nothing. 10, we have 2. So I'm only plotting my nice points, and this told me to go from -6 to +10. 2, 4, 6, -2, 1, -1, 2, 0, 3, 1, 4, 6, 8, 10, 2. To see what the picture looks like, I can go back to my calculator, and I can look at my graph, and I see what it's going to look like. So that's what I want my graph to look like. It's kind of like an S. Being how there's a domain, do not take arrows. You just connect these points. No arrows, don't go past them. That's it. Beautiful. Next one, well, again, it's a graph, so I'm going to put it into my calculator. Y equals the absolute value of x plus 1. So, y equals, the type of absolute value, math, num, ABS. Again, yours will look slightly different than mine. Yours looks better. X plus 1. I go to my table. Now there's no domain. However, being how it is a V, I just want to make sure I get a mirror image. You can go from -10 to 10, but my main thing is I want that mirror image. So there's my mirror image, -4 to 2, 3 to 3. Let's write that down. -4. And then it was 3, 2, 1, 0, 1, 2. Well, -2, 4, -4, 3, -3, 2. Pretty sure I know what this is going to look like. I know it's going to be a V. There's no domain. There's no, well, see, there's no interval. So I put arrows, and that's my graph. State the range. Well, the range, there's no y values down here. The y values start at 0, and they go on forever. So there's a couple different ways to write that. You can write y is greater than or equal to 0. You can write it as 0 to infinity. You can write it as 0 in step-level notation like that as well. Either one is sufficient. Then it says state the domain over which the function is increasing. Well, it's decreasing here, but then when you get to this value, it starts increasing. So at -1, it starts increasing, and that goes on forever. So you can say x is greater than or equal to x is not greater than or equal to. Remember, the turning point, it's neither increasing nor decreasing. So the x is greater than -1, or you can write that as -1, infinity in interval notation, or -1 is less than x is less than infinity in step-level notation. Linear quadratic system. I got to get y by itself for both of them. Now that I have them, I'm going to type them both into the calculator. So I have -x squared plus 2x minus 1 negative x squared plus 2x minus 1. And I have negative x plus 1. I can hit graph to see what it looks like. Looks fantastic. To get the points, I go to my table. It's a parabola, so I need a mirror image in y1. There's my mirror image in y1. So I'm going to copy down this table into two separate tables. They both go from negative 2 to 4. And the first one, I had negative 9, negative 4, negative 1, 0. Negative 9, negative 4, negative 1, 0. Negative 1, negative 4, negative 9. And the other table, I had 3 down to negative 3. 3, 2, 1, 0, negative 1, negative 2, negative 3. Now I'm going to plot points. Negative 2, negative 9, negative 1, negative 4, 0, negative 1, 1, 0, 2, negative 1, 3, negative 4, 5, negative, 4, negative 9. Parabola, arrows because there's no interval. Second function, negative 2 comma 3, negative 1 comma 2. You see it's going to be a line. Arrow again. Now, the solutions are where the graphs intersect. They intersect here and here. This is 1 comma 0. This is 2 comma negative. Make sure you answer the question. The answer to the question is where the graphs intersect. Okay. Same type of problem. Get y by itself, get y by itself. Y equals negative x minus 1. Put it into your calculator. We have x, let's get this up here. Hey, come on, there you are. Y equals x squared plus 6x minus 1, and we've got negative x minus 1. So we're going to hit graph to see what it looks like. Fantastic, it's so pretty looking. Let's go to my table. I want my mirror image. There it is. So I'm going to copy on this table from negative 6 to 0. Negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0. Negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0. And I'm going to get my y columns, negative 1, negative 6, negative 9, negative 10, negative 1, negative 6, negative 9, negative 10. It's a mirror, so it's negative 9, negative 6, negative 1. And then my line is 5 down to negative 1. Let's graph. Negative 6, I'm doing a little overlapping here, oh well. Negative 6, negative 1, negative 5, negative 6, negative 4, negative 9, negative 3, negative 10. I plot all these points. Go. I plot my line. Negative 6, comma 1, 2, 3, 4. Ugh, it's a little ugly. Negative 5, comma 4. Negative 1, 2, 3, 4, comma 3. I plot my points. I draw my line. Now right now I only see one point of intersection. I need to find my other point. So I go back to my table, and I have to scroll so that I find another one. Remember, a solution is where the two y values are the same. This is what a solution looks like. I have to scroll to find another one. There it is, -7 comma 6. So I add that to both tables. I plot it. Let me see if I can move this. That might be a little bit better. A little better. -1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. I've wrote it off before. I connect it to both of them. And my points of intersection are 0, -1, and -7 comma 6. It's also the points that are in both tables. There's -7, 6. And there is 0, -1. Getting close. Ooh, not close enough. Well, we have a system again, but here we have inequalities. We'll graph each inequality. You can either do it in the calculator or by hand. I'm going to do it by hand. This is M, this is B. -4. M is rise over run, up 1 over 2, 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 down 1, left 2. The more points you plot, the better, especially for an inequality. That's not supposed to use it. Bye-bye. Now, there's no equals, so it's a dashed line. It's greater than, so a shade above. Give yourself some nice, good, long lines. Now I have another one. X minus 7. My B is -7. 1, 2, 3, 4, 5, 6, 7. And your slope is up 1 over 1, up 1 over 1, up 1 over 1. So we plot all those points. It's got an equals, so it's solid. It's greater than, so it is above again. Using colors will make this a little bit clearer to see. Now the solution is not where they intersect, but it's where both graphs are shaded. I see green and red in this region right here. Do not touch the actual lines. It wants the coordinates of a point in the solution set. Pick anything in this region. I'm picking 0, 0. But you could have picked any point. You could have picked this point, this point, this point, here, 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 or even here. Any point that's in that region is a point in the solution set. We got another one here. Well, let's get y by itself. So that would be y is less than or equal to x minus 6. So I'm going to do the same thing I just did. Make this a little bit smaller. I throw it off. Whatever, you'll get by. Let's start with this one, minus 6. Slope is 1. Once again, you get these points from the calculator. If you need to, it's got a solid line, so it is a solid line. And it is less than, so it is below. Next, we have negative x plus 7. 1, 2, 3, 4, 5, 6, 7. Slope is down 1 over 1, down 1 over 1. I'm going to plot my points. It does not have an equals, so it is dashed. And it is less than, so I'm going to shade it below. Now my S is the region where they're both shaded. I see both red and black here. My S should not touch the actual lines. It says to state according to a point in the solution set. Any point in here, I choose that one that is positive 1, 2, 3, 4, 5, 6, 7, negative 3. Practice these. You watching me go over one is not going to do anything for you. Average rate of change. We have a song for that. One of my favorite algebra, I think it's my favorite algebra song actually. F of B minus F of A over B minus A. It's not giving you F of B and F of A, so you have to find F of B and F of A. You have to find F of 1 and F of 4. Let's call this one A and this one B. It doesn't matter which one's which. This would be 2 to the first. This would be 2 to the fourth. That's 2. That's 16. So F of B and F of A are 16 and 2. B and A are 4 and 1. 14 over 3. That can't be reduced. That's your average rate of change. And remember, the average rate of change is the slope of the line that connects those points. We got another one here. We got G of negative 2. We've got G of 4. Let's call this one A. Let's call this one B. 2 times negative 2 squared minus 4. 2 times 4 squared minus 4. That is, you can use the calculator, of course. Negative 2 squared is 4, times 2 is 8, minus 4 is 4. 4 squared is 16, times 2 is 32, minus 4 is 28. And again, you feel free to use a calculator on that. And I know my formula is F of B minus F of A over B minus A. You have to have it memorized. I've got a great song to help you remember that. Check out the YouTube site. You're on the YouTube site right now, so you don't have very far to look. F of B and F of A, 28 and 4. B and A, 4 and negative 2. That's 24. That's 6. That reduces. So my average rate of change is 4. Almost there. Which situation could be modeled with a linear function? Well, linear function has a constant difference. I'm adding or subtracting a constant amount. Exponential has a constant, has a constant, I don't want this little comma there, has a constant factor, which means multiplication, or it might be a percent or a rate. So, the height of this is a typo, a ball that's thrown in the air. Well, that's neither. That's actually going to be a parabola. It's going to be quadratic. Because it's going to go up and then it's going to come down. 20%. If it's a percent, it's got to be exponential. The amount of money Jonathan pays for a certain number of gallons of gas at $3.85 per gallon. Every gallon, you're paying another $3.85. Plus $3.85, plus $3.85. That's linear. A bacterial counterlinear which doubles is multiplication. That's exponential. And finally, the last one. The selling prices for a group of cars were recorded when the cars were new and for an additional 5 years. The results are summarized in the tables below. Which car's price dropped at a constant percent rate? Percent rate is exponential. Choice 1, that's minus 5,000. That's minus 5,000. That's minus 5,000. That is linear. So that is not the answer. Choice 2, plus 5,000. Plus 5,000. Plus 5,000. linear. Minus 5,000 minus 4,000. Ooh, so it's officially not linear. So this one is going to be exponential. And this one is plus 5,000 plus 6,000 plus 7,000. So this one might be exponential as well. So it's got to be 3 or 4. It says which car's price dropped. Which one of the prices is getting smaller? Choice 3. So again, your exam is on Wednesday, January 28th from 8 a.m. to 10 a.m. I really enjoyed spending this. Uh-oh. Did it run out of time? Well, I don't know how long I spent. Oh, there it is. Hour and 11 minutes with you. So I just spent an hour and 11 minutes with you. That means that you need to spend a heck of a lot more than an hour and 11 minutes on your own, going through this, practicing it, redoing the problems, looking over your key understandings, going back through old problems, making this homework. You have a lot of work you need to do if you want to be successful on this exam on Wednesday, January 28th from 8 a.m. to 10 a.m. Enjoy. See you soon.